All right, beyond this, here's the other thought that I kind of hope we can move with from yesterday, and then we're going to jump right in and just try to see if we can get these. When we are graphing them, we want easy, convenient radicans. So when we think this out to graph, or when we're graphing, now we could use whatever variable we want. We typically go with f of x, but it could be f of t, and the variable could change. I'm just going to call it x for this one. When graphing, we want to choose x values that make the nth root easy. Now, yesterday, the n that we're looking at was only square. We are going to look today at square roots. We're going to continue and look at some cube roots, and we'll see that, hey, the approach that we're going to use with them isn't wildly different between the two. But as we're going through here, if we can pick x values that make the nth root easy, we're going to be set. Now, some problems will require a bit more scratch work than others, but let's get a couple examples. Are we a standing mood today, or do you want to work at your tables with your neighbors for a couple minutes? Okay, we might mix and match it. We'll go tables for the first example, but if it's not like stellar, then we might switch to standing up and stuff. Okay, for this, as we're going through, we're going to knock out a couple examples. You're going to make a table. So graph with table. Graph with table. Then, what I want us to do is identify for each of the following: domain, in just a second, yes, and range. Okay, so we're going to graph some functions, and we're going to make a table of them and a domain and range. Now, the table is the part that I care the very most about for right now. Hopefully by the end of the day, we might be able to avoid some of this table stuff because, once again, every radical function is simply a transformation of the parent. And if we can make sure that we can see these transformations, maybe we'll be able to save ourselves some time. So, yesterday we did a square root, right? I think. Do we want to start with a square root, or should we kick it up a notch? Okay. So, check it out. Let's say on the first one, I'm going to give you guys 3 minutes, and I'm going to be walking around just like you guys. Excuse me. Just like I can come and listen to you guys talking as you're working on the board, I want to be able to do the same thing here while you're working at your desks. If you and your neighbor wants to turn around to make a group of 4, I'm okay with it as long as everybody's talking about it and working through it. So, our first one. I don't know. How crazy are we feeling? Incredibly crazy. Okay. -2 times the square root of x plus 1 minus 3.
That's crazy.
Not, compared to what we did yesterday, yes.
It is.
Because yesterday we just graphed root x.
Yeah.
I think this is a little crazier. Cool. Your job for me is to make a table of these values. I'll come around and give you guys some graph paper if you want it, or graph sticky notes. I want a table. Now, for these, we're going to say for now, I want 4 points. 4 x values on this table is what I'm after right now. Cool. You may need a little bit of scratch work. You might not. I'm going to give you guys a couple minutes. Any questions before we pause it and say, do this? Also, you guys want to see something crazy? It's not really that crazy for you, but I assure you it blows my mind. Have you guys heard me whine about how I can't pause this screen so that, if I want to work a problem while you guys are, I can't really do it? Have I complained about that? So I assure you I've complained about it a bunch. I don't know if I've complained about it to you guys. I've worked, this is my 10th year here at this school. I've had a smartboard pretty much the whole time. Every year, I've been able to do this. And I can freeze that screen. You guys see me do that all the time. But if I wanted to start working a problem so you couldn't see it, obviously I can't write it up here. Until yesterday, this was discovered. So that's 10 years. I didn't know that this was an option. I've never seen this. I'm drawing on this right now, and you guys can't even tell. Boom. Look at that. All right. So I'm going to give you guys 3 minutes. You are going to make a table of values with this one. I'll come around with some graph paper, and I'm going to be eavesdropping in all your conversations. Good luck. Have fun. Pick to choose in, or plug in, sorry. 1, 2, 3.
-1.
Love it that I heard 4 different answers. I heard Mark the clearest, because Mark is right here. But I didn't hear an answer that I thought I disagreed with. Now, This is kind of subjective, but let's see if we can agree. What's the easiest number to take a square root of? 0. Like 1 is also pretty easy, and most of them are pretty easy if we have them locked in. But 0 is always the smallest number that we can ever take, right? So if I wanted to make this the square root of 0, the scratch work that we could show, or that we can think in our head, depending on how you're comfortable with it, is what's the radicand of this function? That feels like a weird transition. Let me pause. What's the radicand of this function? X plus 1. The radicand is just the stuff we're taking the square root of. And you guys just told me the very first number we wanted this to be was what? 0. If I wanted to make my radicand x plus 1 equal to 0, what value of x should I pick? Yeah, in the future, don't come in and interrupt to grab it. Cool. All right, -1, we'll do it. Now, for these tables, I see a lot of people putting stuff in, and I like the 3 columns. It's not required, but if you make mistakes, I would strongly recommend it. If you're making mistakes on the value that you get for f, I would say use the 3 columns to get a little bit of extra work in here. If we plug in a 1 into this situation, we'll just do this. If we plug in a -1, like you guys said we should, and on this first part at least, you do not have to have this as your first point, but it's what I would recommend as a first. This makes it -2 times the square root of what number? 0 minus 3. What's -2 times the square root of 0? 0. And 0 minus 3? And we get it. Okay. After 0, what's the next nicest square root? So that's not after 0, though. I think I know what your answer. You just need to change the answer a little bit. 0 is a really easy square root. The next easiest is 1. Now, you said 0, and I think you answered the question correctly, Sebastian. I just think that you answered a different question. If the question is, what do I pick to make this equal to 1, then it is 0. Now, if I wanted that scratch work, if I wanted to make x plus 1 this time equal to 1, since these are my nice square numbers, what would we get for x? 0. So, when I plug in a 0, I get -2 times the square root of 0 plus 1 leaves a 1 minus 3. And then let's just think it out. What's the square root of 1 times -2? And -2 minus 3? -5. Now, if we do this correctly, and this middle column is going to help like get this to stick in our head, we're going to see something nice happens every single time. We've taken inside of our work here the square root of 0 and the square root of 1. What's the next nicest number, Kennedy? We did the square root of 0 and the square root of 1. What's the next easy one? What's the square root of 2? So I don't think it's easy, but there it is. Because I heard you say it a second ago. So there we are. If I wanted to make my radicand, x plus 1, to be the next nice squared number, what do we get for x? 3. Now, if I pick 3, and I'm going to jump ahead a step here, what happens with this radicand? It's now a 4. And once again, we get another lovely, wonderful square number to deal with. Could we do it with not wonderfully nice square numbers? Yeah, but unless you want to plot a bunch of really gross decimals, then probably the better way to go about it. What's the square root of 4? So this becomes -2 times 2, which is what? -4 minus 3? -7. Now, I asked you guys to do 4 points. I'm only going to do 3 because I think we're going to have enough information to get the graph clear. But what's the next x value you would choose? If you plug in a 4, I don't know the square root of 5. But you said if I pick an 8, it would make it the square root of 9. And do we know that one? Oh, man. Like, just let's pick those easy ones. Okay. From these, we're going to get a quick graph. And I'm going to pop over to Desmos to get some graph paper. So we'll do this. We'll snip it real quick. If I'm thinking about my scale, and I don't really have to because I can just copy and paste, but you guys certainly should be thinking about your scale as you're going. I need x values that are kind of positive and y values that are negative. Which quadrant am I in? Mostly quadrant 4, right? Positive x, with the exception of not entirely because I need -1. So if I'm trying to pick out my scale, and I'm just copying and pasting it, but I'd say it's kind of the same as you guys. Sorry, I'm going to get this to without numbers. Kind of the same as you guys draw on your own if we're just trying to decide how big should it be. I think I need a little bit to the left and a whole lot more to the right. Like this is the region of the graph that I'm going to be looking at. Can we all agree with that? Mostly the positive x values and negative y values associated with them. So if we take this, and I have a nice graph, and you guys should have a fairly nice graph, but let's see here. I need to go how far to the right in my scale? I only need to go 1 to the right? So I'll go 1 to the left. I'm okay with that. And how far to the right do I need to go for my x-axis? 3. And it just coincidentally works out really nicely. There's 1, 2, and 3 for mine. Now, is it possible that my y-scale needs to jump by bigger pieces every time? Absolutely, it's possible, right? So let's think that out. I need to get down to as low as what on the y-axis? -7. So these all have 4 ticks. My natural thought is to call this -8. Only because the way that my graph is set up. Each one of these ticks would be 1 unit, which means that's -4. And now I think I might have enough to start graphing this thing. Is it okay if you want to do the big 10 by 10 scale and waste a bunch of space? For sure. I'm going to have a better looking graph than you will, and that's okay. Cool. I would encourage you to start getting here. From this point, let's just start plotting our points here. -1, -3. Looks like it'd be right there. Okay. 0, -5 lives here. And 3, -7 is all the way over here at this one. Do those 3 points form a straight line? No. Should they form a straight line? No, definitely not. It's a square root function. It should look like this. Somehow, like this. Okay, so I'm going to struggle through this real quick. I want you guys to help me identify what I've done wrong. I'm going to do it in parts. We'll do this first one here. And I just want everybody to take a second. That's the closest I've ever come to hitting 3 points that far apart ever on my board. So let's get a round of applause real quick. With emotion. All right, good. All right, so here's my graph. No, what do you mean no? Why not? So why not is the question at hand. Angel said no pretty aggressively, and I appreciated it, but he could not justify it. 30 seconds with your neighbors, going to cold call somebody. Why doesn't my graph do that?
It starts to take negative square roots.
Otherwise it'll be a
Negative square roots. And then imaginary. You can't graph it.
It just doesn't kick out to be I want to go at like 6:45. I don't want to see it's not worth watching.
That's a very positive one.
Yeah, okay, well then I'm okay saying I don't want to go watch the
Ooh, there is a circle. You think that
try and count I did the bar with like I think this
Okay, so check it out randomly. Okay, if we're not quite sure, like these were the points that I had. My first part of the graph was just this side of the red. And I extended it. I drew it up through here because that's what the curve seems to follow. If I tried to plug in -2, what happens to this radical? It becomes the square root of -1. Which, what's the square root of -1? It's I, the imaginary unit. Where on the real number line right here would I put I? Yeah, if we wanted to think about it like nowhere is the right answer, just so you know, because you can't put it on the real number line. If you wanted to add the imaginary stuff, you could conceivably have an axis spitting out like this that would give us the imaginary part, but we don't deal with the imaginaries. Which means when we look at our graph, where you tell me when it stops or when it starts. I don't know how you're interpreting that question, and I'll make this smaller. I need to get rid of some of the graph that didn't work, and we'll go a little bit bigger for that. There we go. Landa, will you close the door also? Okay, This is where my function is defined. It's the only places that my function is defined. Now, beyond this, once we've gotten here, 2 more questions regarding from the original, and then we're going to try to tie it back together with everything else that we've seen. For this function, f of x that we have graphed up here, if we wanted to talk about the domain of this, the domain of f of x, how would we say this? What x values can I actually plug into my function? It can be an interval or it can be set builder. I'm okay with either. So I heard x such that, and then I heard some other murmuring, but I didn't quite catch it. Greater than what? Okay, I love this almost. Or equal to. I can take the square root of 0. Now, does this relate in any way to our radicand? Definitely. Like, these two are connected, right? Now, there is a really convenient way to sort these out. We'll summarize that here shortly. What about the range of this lovely function, f of x? It's a set of y's such that something's true. And Michael, you got it last time, so I think that you're about ready to fire this one too. Anybody but Michael or Lily right now? No, you haven't answered a ton today. You can answer if you want. Talk with your neighbors. Same thing, 10 seconds. I'm a cold call. For real this time, though. Why aren't you taking notes? Yes. For sure. Yeah. Okay, 3, 2, 1, and random number. Let's see if we get somebody that's in class. 1. Who's number 1? Are they not here? Is it you? All right. What do you think the range is? I disagree with that because I don't touch any of those y values that you just read me. What's up? That's what I needed. The first time you said greater than. What is every y value on our graph or table smaller than or equal to? -1. And we done. Now, are you sure? It's -3. What am I talking about? You should be sure. You should be sure. Yes is the appropriate answer there. That's my bad. Okay. With these, last little question. From this graph right here, you do not have to add this onto it. I'm going to sketch the parent function real quick. 0, 0 is on it. And 1, 1 is on it. And 4, 2 all the way up here. This is the parent function. This purple one. Now, I can't see all of it. And you guys don't have to have it on your graph. But this is what we saw the parent function yesterday look like. If I wanted to go from purple to red, what sort of transformations must I have made? So we can go 3 down. So if I do that right now, 1, 2, 3, the graph would now look like this. So you say flip it. What do you mean by flip it? So reflect it over what? So here's my concern. If we moved it down and then reflected it, I wind up here, don't I?
Well, no, don't flip it yet. Just reflect it.
Oh, reflect it first?
Yeah.
Oh, okay. Like, okay, I'm fine with that. I can reflect it first if you want to.
And then move back 4 down 3.
So now I move down 3. Down 3. And left how many?
4.
Why 4?
-4.
Why -4?
Because that's where the dot is.
Are you sure?
Yeah.
I think the scale got weird. I move left how many?
4 of the squares.
4 squares, which is how many units? Why would I move 1 to the left looking at this function? Because it's been translated 1 to the left. That's exactly what our transformations tell us happened as well. Okay, looking at these things. If you are super comfortable with the square root and you can envision that we move left down, we move left 1, we reflect, and then we move down 3 if we follow order of operations, then that's awesome. If you can't envision this in your mind, it's not the end of the world, because as long as we make our radicand, nice numbers to take the square roots of, these tables are pretty straightforward. Cool, cool? All right. I'm going to throw you guys a 12-6 real quick. I'm going to watch baseball in here. Okay. So I don't watch any baseball, to be honest, but a 12-6 is a curveball. So I'm going to try to throw you guys a sneaky problem. You're going to pick one person at your table, and that person, I don't care how you pick, you can do a game of rock, paper, scissors. That person's going to stand up and go join a separate group. One of you in your group is moving with your notebook here in just a minute, or you're just going to decide who's moving. I'm fine with that. Everybody, decide who's moving at your group. Stand up, join a different group, and by the time you sit back down, I'm going to have another problem up at the board for you. All right, so once you guys are in your new wonderfully warm and uncomfortably different temperature seats, right? It's weird, it's different temperature than when you sit, which is an odd thing because we're all humans and we're all the same temperature. All right, regardless, check it out. Here's your problem. What have I changed? Oh, cube root. Weird. I want you to use 6 points on this one. I would encourage the 6 nicest points. I'll tell you 216 is a cube. I would not use 216 on this graph, unless you want to have an x-axis that goes out to 216. Cool. I want you and your neighbors, small groups, make me a table for this one. Volunteers, I want the easiest number to take a cube root of. 0. If I wanted to make my radicand 0, what value of x would you pick? Does everybody have 1 on your x value somewhere? Okay, here's where we're going to differ. I'm going to put my 1 value right here. When I do this, I get the cubed root of, not that. I'm just going to write it out nicer. The cubed root of, if I plug in a 1, what's 1 minus 1? And what's the cubed root of 0? Plus 2. Okay, as I was coming around and looking at stuff, I could see very clearly that a lot of you guys chose 1, and that's the right choice. I'm cool with it. Why did I put mine so far down? Maybe I'll add some negative values, but we'll get there. Okay, after 1, the most common number that I saw was, any guesses? 9. Why is 9 a wonderful number to choose here? It makes 9 minus 1, which is the cubed root of what now? 8 plus 2. And then we have this, and the cubed root of 8 is, and that's the answer I was getting from a lot of people. Cheska confidently tells me it's 2 plus 2 is 4. Okay, cool. So we got 2 points. What's the next value of x we should pick?
We did 20.
I think 28 will work. And I think that, do you have 28 or 27 written?
I said negative.
You said negative 7. Okay, well, I'm going to switch gears here then. I did not catch that. Kennedy suggested negative 7. Interesting. Why is negative 7 an awesome choice? I'll get negative 8. Now, we're going to pause on this one for a second. That was a great choice, by the way. Looking at this, what's different about this problem than the first one we did? It's cubed. Do me a favor real quick. What's negative 1 times negative 1? Times negative 1 one more time. So we did it thrice. Negative 1. I can multiply by 3 negatives and get a negative. I can't do that with squares, right? Because negative times a negative is always a positive. Which means for the vast majority of you, I love the points that you've chosen, but you've only chosen about half as many as I think we should have. What number do I multiply by itself 3 times to get negative 8? Negative 2 times negative 2 times. Hey, that does it. So when I get here and I see that this is just negative 2 plus 2, what does it come? 0. Well, man, that was at negative 8. Any other values that you guys came up with? 28 is a wonderful choice. It makes this the cubed root of what number? 27 and plus 2 all the same. What's the cubed root of 27? Good. 3 plus 2? 5. I'm going to get us one more value is all that I really truly need right here for now. 65 is a decent choice, but I'm going to go the other direction. What would I, so I know -8 worked and +8 worked, and we just chose -27. So it seems like there's a bit of symmetry happening here. Is there a value that I could get -27? If I pick -26, I get the cubed root of -27 plus 2. What number times itself 3 times gives me -27? It's not 3. You're close, though. -3 plus 2
1.
is, are you sure?
Negative.
-1. Now, we are getting a whole bunch of different points, and it is natural that if we do the square root one first, you're like, of course you're going to leave off the negatives, but we can't overlook them. Odd roots are fine with negatives. Even roots struggle. We have to go imaginary with it, but odd ones are fine. So whether it's a cubed root, a fifth root, a seventh root, irrelevant, we can do those of negative numbers. Now, when we start graphing this, just so that it's a little bit more like what you have, we're going to go ahead and do this bad boy. And let's see here. I'm going to pick a kind of ugly scale, and it's going to be really rough. How far to the right do I need to go?
65.
So on mine, and I'll do it here, that's fine. Out to 30? That seems reasonable to me. So can we all agree that that's 30? And then this must be what? -30, but I'll take it. And then I can pick a much nicer scale for my y-axis. Up to 5. So I'll just say there's 5. So 5, 4, 3, 5, 4, 3, 2. That was much better. Okay. What's up? Gosh darn it, it wasn't much better.
What?
There we go. I had 4 ticks going up to 5, and I didn't notice it. Okay. Now, I have rough graph here. Can we plot these points reasonably well? Okay. Do you need to have me talking out how to plot these points? Okay. I'm cool with that. -26. And I'm going to talk out loud, but you can graph your own. I'm just not going to go crazy through it. -7 and 0 is probably about there. And 1 and 2 looks like it'll be about here. And 4 and 9. What? 9 and 4, sorry. Goes up to about here. Then 28 and 5. Now, if I only look at this one little section to begin with, does it kind of look like what we had? Does it look like a radical to you if I just do that first part? I think so. Now, what's different though is that we do get to use these values on the left. It has to switch the way that it curves. Now, we're not going to use this word crazy, but right now, does this look more like a sad parabola that opens downward or a happy parabola that opens upward? This part right here, does it curve more like a down parabola or does it curve more like an up parabola? A down parabola. Can we all agree that it has that same general curve shape? Okay, in this situation, just a little bit of front loading on stuff that we'll see in future classes. We say that this graph, this little section is concave down. It's curving in a downward fashion, like that downward parabola. It doesn't mean it's getting bigger or smaller. It just tells me about how it curves. When I switch here and I graph the other part of it and run through the other points, this second half that we're looking at, I'm going to miss that point. Does it curve more like a happy parabola or a sad parabola? This section, it curves up like a happy parabola, right? So if this was concave down, what do you think we'd call this? Concave up. And we have our wonderful cube root graph. Now, we started this one a little bit further ahead than we did the others, are the square roots. I did not start with the parent. This is the parent that's been moved in a particular way. How has this parent been moved? Don't shout it out. I want you like 20 seconds really quietly with your neighbor. Based on what I see here, the parent function has been moved somehow. I just want you guys to tell me how. I know we don't see the parent function, but we're seeing if we can make sense of the h's, the k's, and c's is how I wrote it. What is the transformations, or what are the transformations? X minus one.
I don't know. I don't really want to move the other one.
So careful.
No, wait.
I liked your first thought.
Backwards in this way.
Up, right one, and this is gonna, and it's weird, and I know that. That's the only one. Okay, anybody want to volunteer? How did this graph move? What's the value of h in this? Or c in ours? It's a 1 right now. And if it's a +1, my graph should have moved how many which way?
Oh.
To the right 1. Now, this is the weird distinction here. Like, here's the wonky part. This C value, or the H value, is x minus, what's that number? 1. And that number was positive 1, right? That tells me 1 to the right, even though it shows up as minus, because all I care about is that value of H. What's the K value? Plus 2. So if I were to take the same graph and undo that, and you don't have to sketch this one on yours, but if I took this whole graph and I moved it 1 to the left and 2 down, I think that I'm going to get the parent function. Okay, I'm not going to sketch a parent function here because my scale is going to make it look not as nice as it would, but I see the transformations. Anytime we're doing these, we're after making this the nicest number possible. Why is what in the middle? I didn't move 1 to the right. I didn't move 1 to the right. You are 100% correct. Did anybody else notice that I plotted the point 0, 2? Did you guys plot 0, 2, or did you plot 1, 2? I probably should have talked out doing the graph because I made a mistake in the process. I'm going to try to fix this so it looks a little bit nicer. That point was just a little off, right? So my graph is going to get real ugly for a second. Would you agree that 1, 2 is like closer to here? And it'll curve a little bit, but it'll still do the same shape. It's ugly, sorry. Okay, is this crazy hard? Easier than what we were doing before?
Yes.
Oh, good. So you guys love graphing again. Huh, interesting that you just said yes and no. Weird. All right, over the weekend, I'm going to hook you up. I'm not going to give you a book assignment, but don't worry, I don't forget about things that I want you guys to do and not be bored over the weekend. So, check it out. Before you leave, I'm going to physically hand one to you so that people can't say, oh, Holloway, I didn't grab one off the thing the other day. Don't worry, I'm going to physically put one of these in each of your hands. You guys can pack up. I got wonderful factoring sheets that I would encourage you to read the directions of. Wonderful.
Yeah. Thank you.
Mark, would you do me a favor on the keyboard or up there? Will you just go to the pause button and hit pause on my laptop?
Yeah.